Hi students, welcome to my channel. In this video, I am going to discuss problems related to Leibniz rule. First, what is Leibniz rule? How to apply Leibniz rule for the given problems in integration. See that first Leibniz rule. The derivative of, that means d by dx of integral phi of x to xi of x f of t dt. How to differentiate these type of integrals? See, which is equal to differentiation and integration will be cancelled. Why? Because integration is the inverse process of differentiation, or differentiation is the inverse process of integration. So these two will be cancelled. After that, only this function will be there. F of, in place of t variable, we have to write that upper limit. That means f of xi of x into, again this function differentiation we have to write. That means the derivative of this one, xi dash of x minus, in place of t variable lower limit we have to write f of phi of x into the derivative of phi of x function. That means phi dash of x. This is the Leibniz rule. Now I am going to give some examples regarding this formula. See the question, limit x tends to 0, x power 4 divided by integral 0 to x square tan inverse t into dt, which is equal to, options are given by 0, 1, 2 and 3. These are the values. First you have to substitute x is equal to 0 in this. Here also if you substitute 0, in lower limit and upper limit will be zeros, that integral cannot be exist. So this value will be 0. 0 by 0 means indeterminate form. Whenever 0 by 0 indeterminate form, you have to apply L'Hospital rule. Whenever it is L'Hospital rule, limit x tends to 0, derivative of x power 4, that means 4x cube divided by denominator's derivative, that means d by dx of this function. It is looking like d by dx of this formula, Leibniz rule. That is we are going to apply. So first, in place of t variable, apply upper limit. Means tan inverse of, in place of t, x square into, again according to this formula, x square differentiation we have to write 2x minus f of, again in place of t variable what we have to write, lower limit, tan inverse of 0, 0 derivative is 0. You remember that very important note in this, whenever lower limit will be 0 or any constant, it should be always the value will become as 0. In the next step, limit x tends to 0, 4x cube divided by, this complete value is 0. So 2x into tan inverse of x square. Here x cancel, x square times 2 ones are 2 twos are will be cancelled, which is equal to 2 constant you can take outside. Limit x tends to 0, x square divided by tan inverse of x square, which is equal to 2 into, this also can be written as limit x tends to 0 means as x square tends to also 0, tan inverse of x square by x square. We have standard yield. Limit x tends to 0, tan inverse x by x is 1. So this value will becomes 2 by 1, which is equal to 2, which is there in the third option. So third option for this. One more question we'll take regarding this. Question number 2. Limit x tends to 0. Integral 0 to x sine cube t into cos t dt whole divided by x power 4. The options are 0.25, 2.5, 5.2, 0.52. First, according to the given limit, x is equal to 0, if you substitute this value, will become 0, and here also 0. Again we are going to get 0 by 0 form. Whenever we are getting 0 by 0 form, L'Hospital rule we have to apply. So limit x tends to 0. First apply here Leibniz rule in the numerator. Sine cube of, in place of t, x you have to write, into cos x. Again x derivative is 1 minus, I already said in previous problem, whenever lower limit will be constant or 0, so the next term is going to get 0. No need to do. Divided by derivative of x power 4 is 4x cube. Now 1 by 4 we can take outside. Limit x tends to 0. Sine cube x divided by x cube. This can be expressed as sin x by x whole cube into the rest of the function limit x tends to 0 cos x, which is equal to 1 by 4. Limit x tends to 0 sin x by x is 1 power 3, 1 cube. Limit x tends to 0 cos x value is also 1. So 1 into 1 by 4, which is equal to 1 by 4. 1 by 4 can be written as 0.25, which is there in the first option. Next, more examples in this. More 3 examples. Limit x tends to 0. Integral 0 to x tan square t secant square t dt by x cube. Again here also we are going to get 0 by 0 form. So by applying L'Hospital rule, while applying L'Hospital rule in the numerator we have to apply Leibniz rule. So according to Leibniz rule, tan square x into secant square x into 1, x derivative is 1, minus constant, whenever constant is there lower limit you have to write 0, divided by x cube derivative is 3x square. After that 1 by 3 we can take outside constant, and limit x tends to 0. Here product of two limits you have to write tan square x by x square, that means limit x tends to 0 tan x by x whole square, and rest of the function is limit x tends to 0 secant square x, which is equal to 1 by 3 into, we know that the standard result is 1 square, x equal to 0 substitute secant 0 is 1, which is equal to 1 by 3. So 1 by 3 is there in the third option. Come to the next question. Limit x tends to 0. Integral 0 to x square sine of root t into dt by x cube. Here also we are going to get as 0 by 0 form. So we have to apply Leibniz rule for the numerator, L'Hospital rule. While applying L'Hospital rule for the numerator, we have to apply Leibniz rule. So limit x tends to 0 sine of root x square into x square derivative is 2x minus constant is there here, 0 is there. So 0 derivative is 0, no need to write remaining. Divided by derivative of x cube is 3x square. So 3 constant you can take outside. Limit x tends to 0 sine x root x square means x into 2x, even 2 also constant you can take outside. So 2 by 3 divided by x divided by x square. Here one of the x cancel, 2 by 3. Limit x tends to 0 sin x by x, which is equal to 2 by 3. This is the standard result, this value is 1. So 1 into 2 by 3 is 2 by 3. 2 by 3 is the second option. So last model in this Leibniz rule. Here also we are going to get 0 by 0 form. You have to apply L'Hospital rule. In L'Hospital rule for the numerator we are going to apply that Leibniz rule. So according to Leibniz rule, sin of in place of t upper limit sin x into x derivative is 1 minus sin 0 again 0 derivative is 0, all are zeros only, divided by sin of x square derivative is cos of x square again x square derivative is 2x. So constant is here 1 by 2. It is in the denominator, you can take outside 1 by 2. Limit extends to 0. Sin x by x into rest of the function, limit extends to 0, 1 by cos x square, which is equal to 1 by 2. This value will become as 1. This value is also 1 by 1, which is equal to 1 by 2. 1 by 2 is there in the second option. So please do subscribe to my YouTube channel. If you have any doubt, please write to my inbox, I will respond. Thank you very much for watching my videos.